right, remember in pre-calc when we learned about inverse functions? So when you basically swap the x and y values, right? So if the original function was y equals x cubed minus 1, the inverse would be to swap the x and y's would be x equals y cubed minus 1. And then you would resolve that equation for y, right, which is right here. And we would say the inverse of the original function is x plus 1 to the 1/3 or the cube root of x plus 1, right? So this is just notation for the inverse of x. And remember, if you're looking at it graphically, the inverse function can be obtained by reflecting the original function over the line y equals x, right? So it's a reflection over that line. So how in the world do you find derivatives of inverse functions? I will admit that this one always makes my brain hurt. I feel like I have to hold a lot of information in my head. But I'll show you, and so I had to create steps for myself to figure this out. But maybe you guys will get it more intuitively, but I'm going to share my steps with you. So there's two different kind of notations to set up the derivative of the inverse function. So let's read this. Slopes at inverse points are reciprocals. So if the point AB is on the graph of f, and G is the inverse of f, then, okay, first thing we need to know is that we're talking about this point AB, a specific point, right, an x and y coordinate. If you're trying to find the derivative of the inverse, and they're saying just call the inverse function G, right, so the derivative of the inverse function evaluated at the y value, right, because it's the inverse, the way you would find that is take 1 over the derivative of the original function evaluated at a. So in order to solve this, you need to first find the derivative of the original function, and then you also need to find out these 2 points A and B. Okay? So another way we can talk about it is if we write it with this inverse notation in it. So the derivative of the inverse of x can be found by 1 over the derivative of f evaluated at the inverse f prime of f inverse of x. So that means you have to find the inverse evaluated at x. Then once you get that value, you'd plug it into the f prime. So this part right here, the reciprocal of the derivative of f that's evaluated at the inverse point. That's kind of the quick way to say all that. The reciprocal of the derivative of f evaluated at the inverse point. So I'm gonna show you an example. I think that's a lot of words. Sometimes it's easier to see with numbers. So example 1 says to find the derivative of the inverse of f at 7. Okay, and they give us f. F is 5 minus 2x cubed. So these are my steps. I wrote them down here. I just redid all these problems from last year so I could remember. Like I said, this is tricky for me. So the first thing we need to do is actually find the inverse. Okay, so let's find f negative 1 of x. Okay, so to find that, we need to swap our x and y's. So here, instead of y, we're going to have x equals 5 minus 2y cubed. All right, now we need to solve for y. So we end up with x minus 5 equals negative y cubed. Oh, Miss Harrington, you forgot the 2. There we go. So then we end up with x minus 5 over minus 2. And all of that has to be cube rooted so that we just have y on one side. So this is the inverse function, right? So now, let's see what I want to do next. Now we also need the derivative of f. So let's find the derivative of f. Well, that's easy. That first part goes to 0, and minus 2x cubed just becomes minus 6x squared. So the derivative of f is minus 6x squared. Okay, so we have our derivative, we have our inverse function, but we need to evaluate this inverse function at the given value of x. So my third step is going to be evaluate the inverse function. We'll just call it at the given value because they gave us 7. Okay, so that means that the inverse evaluated at 7 is going to be what? It's going to be the cube root of 7 minus 5 over negative 2, right? I'm just plugging in 7 into my inverse function. So then I get the cube root of 2 over negative 2, which means the cube root of negative 1, which means the inverse evaluated at 7 is just negative 1. Okay, so now I kind of have everything I need, right? I have my derivative, and I've evaluated the inverse at x. So my answer here, f negative 1 prime of 7 is 1. So here's my fourth step, actually solving it, over f prime of, so f prime of what? Whatever this value is here. So that came out to negative 1. You see that all of this, f negative 1 of x became negative 1. So this is just f prime of negative 1. So now I can actually solve that. What's f prime of negative 1? It's 1 over negative 6 times negative 1 squared, right? I'm just taking f prime from there, which means that this is 1 over negative 6. So that is the solution. So in order to find the derivative of an inverse function, I need the derivative of the function, and I need to find the inverse of the function and evaluate it at that point. So I know it might seem a little weird. Let's try another one. Okay, here it says find f inverse prime, so the derivative of the inverse at 2 for this function. So let's use our steps first. Flip this over to make sure I use the same steps. So 1, let's find the inverse because we need that. So we can just say find f negative 1 of x. All right, so let's switch this. So it would, instead of y equaling that, it's going to be x equals y plus 3 over y plus 1. Now we have to solve for y. So I'm going to cross multiply. So then I would end up with xy times, okay, x times 1 is plus x equals y plus 3. I gather my y's on one side, so I have xy minus y equals 3 minus x. So I can factor out a y. So then I end up with y equals 3 minus x over x minus 1. It's my inverse function, okay? Now I need to find the derivative of x. So this is a quotient rule, right? So u equals x plus 3, v equals x plus 1, u prime equals 1, v prime equals 1. Well, that makes it a little bit easier, right? So then my quotient rule says that f prime of x equals v times u prime, so that's x plus 1, minus v prime u, well that's x minus 3, all over v squared. Okay, now when I'm looking at this, I can see that these x's are going to cancel out, and 1 minus 1, this becomes plus 3 equals 4, right? Let's see. So x minus x, oh, Miss Harrington, that's a plus. I was like, wait, why is my answer different? X minus x goes away, and 1 minus 3 is negative 2. And I'm sorry I keep talking to myself in the third person. It's kind of weird. That's what happens when you're in a room alone for hours just recording math videos. You lose it. It is not as fun as being in the classroom with you guys. Okay, so I have my derivative function. Now, let's evaluate. Let's evaluate the inverse function at 2, right? That's the point they gave us. So here's our inverse function. And when we evaluate it at 2, we get 3 minus 2 over 2 minus 1. So that comes out to be 3 minus 2 is 1, and 2 minus 1 is 1, so that's just 1. Okay, so my last step here is to, remember we're doing this thing, right? So let's just rewrite it. F negative 1 of 2. So the inverse of f at 2 equals 1 over f prime of, well, we already evaluated the inverse at 2. We got 1, so it's f prime of 1. So we're taking all that and just plugging in a 1. So now, let's solve this. I'm going to go down here. So the inverse evaluated at 2, I'm forgetting my prime here, doing the derivative of the inverse evaluated at 2, right? Equals 1 over, well, f prime is here, and I need to evaluate f prime at 1. So I'd end up with negative 2 over 1 plus 1 squared, which means that's 1 over negative 2 over 1 plus 1 is 2, 2 squared is 4. That means this is equal to negative 4 over 2, which means this thing has a value of 2. So right there is our solution, negative 2. All right, so I know that's a lot of steps, so let's take a step back and think about the concept. Look at this multiple choice question. So it says an increasing function f satisfies f of 10 equals 5 and f prime of 10 equals 8. Which of the following statements must be true? Okay, so if I know f of 10 equals 5, that means I know for f of x there is a point on that graph that lies at 10 comma 5, right? When I plug in 10, I get 5. That means on the inverse, it would be swapped. There would be a point 5 comma 10. All right, so they want us, let's just start with this. The first one says the derivative of the inverse evaluated at 5. The derivative of the inverse evaluated at 5 equals, well, you equal 1 over f prime of the inverse evaluated at 5. Okay. So what is the value of the inverse evaluated at 5? Well, the inverse evaluated at 5 is going to be 10, right? It tells you if I plug in 5, I get 10. So that means I would have 1 over f prime of 10. Okay, well, what's f prime of 10? They gave us that. F prime of 10 is 8. So if I evaluate the derivative of the inverse at 5, I get 1 over 8. Well, this thing says 10, so that's not true. There's two more that talk about the derivative of the inverse at 5. One is that it equals 8. Well, we know that's not true. And this last one says it equals 1/8, which is what we got. So I know that's true. But let's just check on B. And let's see if B is true. So B says, what's the value of the derivative of the inverse at 8? Well, I'm just going to write this because it helps me. It's equal to f prime of the inverse evaluated at 8. Okay, well, what is the inverse evaluated at 8? You guys, I wrote this. I'm realizing that I should have put -1 there. Hopefully you notice that. That's the inverse. It wasn't supposed to be f prime. It's supposed to be f inverse of x. So it's asking me to find the value of the inverse function at 8. I have no idea what that is because it only gave me the value of the inverse function at 5. So this, I don't know. So I can't evaluate this. And because I can't evaluate this, I don't know if this is true. It could be true. So the only one that must be true is D. Okay, see you next time.